All right, today we are starting section 6.4. We will at least spend today and tomorrow on it. We will also review it on Wednesday, and our goal will be to take a quiz over it on Thursday. Okay, we will adjust that plan as necessary. For 6.4, we are going to use the sum and difference of cube patterns and solve polynomial equations of that type. Okay, so we're learning a new factor pattern, and we are going to apply some of our old knowledge from last semester to solve polynomial equations. All right, you might recall from last semester that a quadratic expression that is the difference of two squares has a special factoring pattern where a squared minus b squared was equal to a plus b times a minus b. These are the ones that we said we factored using square roots when we factored them. Do we remember these? Two people do? A couple other head nods. Okay. So similarly, a cubic expression also has a pattern for both sums and differences. So squares only had a difference pattern. For cubes, we can do sums and differences. So these are the factoring patterns for the sum and difference of cubes. Obviously, the sum would be the one with what symbol in the middle? A plus sign, and difference has a minus sign. Okay, so the top is the sum pattern. So if you have a cubed plus b cubed, it will factor into a plus b times a squared minus ab plus b squared. If you have a cubed minus b cubed, it will factor into a minus b times a squared plus ab plus b squared. So notice that these are essentially the same pattern. They are super similar. What's the only difference between them?
Subtract and the plus.
Okay, where the plus signs and minus signs go. So here we go, plus, minus, plus.
Minus, plus, plus.
And on the bottom we have minus, plus, plus. So we got to keep those straight. So the way that it helps me remember it is that the back is always plus. The very back is always plus. Okay, for the sum, the a and b alone is a plus. That's a sum. So that means the minus sign has to go over here. Okay, for the difference, the a and b that's alone has the minus sign. So that means the other one's a plus. Whatever helps you remember it, it's up to you. We got to get these memorized, though.
Plus,
okay?
Plus, minus, plus.
Well, we are asked to factor the following. X cubed minus 8 is our first one. The second one is x cubed plus 64. So is our first one, number one, a sum or difference? Difference. So if you want, you can set up your parentheses right away with your signs if it's going to help you out. What sign's going to go in the front? Minus. The sign in this front one, the little parentheses, is always the same as your starting sign. Minus. Then my other two signs are going to be two pluses. Plus and plus. If it helps you to fill in your signs right away, I would do that. Now, when we were doing the sum and, or it's not the sum and difference, just the difference of squares, we square rooted to figure out what our terms were. In this case, we're not just squaring, we're cubing. So we're going to have to take the cube root, which is a little bit harder. For the x cubed, it shouldn't be so bad. What do you think the cube root of x cubed is?
X squared.
Just x, right? If you take x times x times x, that's what gets you x cubed. So the cube root of x cubed is x. If you want to put a little cubed root symbol in front of it, you can. It looks like a square root symbol with a 3 in the index, the appropriate term for it. So we have to do the same thing for for the 8? The cube root of 8.
2.
2. Okay, because 2 times 2 times 2 is equal to 8. Are we all okay with that? So it's more than just square rooting, it's cube rooting. Some calculators will cube root numbers for you. Not all of them. I would recommend kind of memorizing your perfect cube numbers, kind of like at some point in time a teacher I'm sure told you to memorize your perfect square numbers. Your perfect cubes would be 1, 8, 27, 64, 125, 216, I think 343, and then I don't have them memorized quite as high as I should on those, but you get the idea. Okay, so a number times itself 3 times. Now we have to fill in the back part of our parentheses. All right, getting the first set of parentheses is the easy part, the little parentheses, and that helps us with the back parentheses. So in the back, in your factoring pattern, this said a squared. So whatever you put in the front of your first parentheses, you're going to square it. So what goes here? X squared. In the very back of the parentheses is what we called b squared in our factoring pattern. So in this case, that would be 2 squared, which is 4. And in the middle, we took a and b and multiplied them together. So here my a and b are x and 2,
2x.
so 2x. If we wanted to check ourselves, what do you think we could do?
Plug it in.
Not quite plugging in. What operation do these parentheses imply? Multiplication. So we could multiply or double distribute back out, combine like terms, and we should end up with x cubed minus 8. And I'm not going to make you take the time to do that right now because we've got a lot of other stuff to do. But it's important that you know that you can check yourself on these. Okay? If you really care to take the time to do it, you can check yourself. All right. On number 2. This time, do we have a sum or a difference? A sum. We got a plus sign. So let's fill in our signs first, and then we'll go back and fill in the terms.
Plus, minus, plus.
Good. For a sum, we have plus, minus, plus. All right, in order to figure out what goes in the first set of parentheses, we take the cube root of both terms. What's the cube root of x cubed?
X plus 8.
Just x. Now be careful when we go to take the cube root of 64. 4, okay? Because if we take 4 times 4 times 4, that gives us 64. That's how we're coming up with that number in the back. Questions about that? Once you have that much of it filled in, the rest of it should go pretty quickly. Okay, we know that the first term in the second parentheses is going to be
X cubed and squared.
x squared. The back term
16.
is 16. So we take 4 times 4, we get 16. And in the middle,
4x.
we multiply those two terms together, we have 4x. So if you need to show yourself a little more work, you could kind of write out what we talked through here. The first one's x squared. The middle, we multiply the 4 and the x together. The last one, we take the 4 and square it. Okay, but this down here is our final answer. What's different about 3 and 4? We got numbers in front of the x's. That's really not going to change our process a whole lot. It'll just change our answers a little bit. So again, we're going to focus first on our signs. What are my signs for number 3?
Plus, minus, plus.
Plus, minus, plus. We have the sum pattern. That's the order our signs go in. In order to figure out what goes in our first set of parentheses, we are still going to cube root the terms. So when we cube root 8x cubed, we cube root the 8 and the x cubed at the same time. So the cube root of 8 would be 2. The cube root of x cubed is x. So all together, that gives me a 2x. For the back part of that first set of parentheses, we have to cube root 125. That would be 5. Now when we move into our other set of parentheses, I'm going to show another little step up here. We're going to have to take 2x and square it. In the middle, we're going to have to multiply 2x times 5. And in the back, we're going to have to square the 5. Okay, so this is kind of like showing work or showing how we're coming up with what goes in those parentheses. It's the same factoring pattern. We square that first term in the front. We square the last term in the back. We multiply them together in the middle. When I square 2x squared, when I square 2x, what do I get? Good. That becomes a 4x squared. The whole thing's getting squared, including the 2. In the middle, I take 2x times 5. 10x, good. And then on the back, 5 squared is 25. Questions, concerns? So this whole thing is our answer. We're ready for number 4? Not quite. Almost. On number 4, do I have a sum or a difference? A difference. So what are my signs? Good. Minus, plus, plus. All right, for my first set of parentheses, the little one, we take the cube roots. What is the cube root of 27x cubed? 3x, good. So 3x, and the cube root of 1 is 1. So in our second set of parentheses, again, I'll write it out above what we're doing. We're going to take the 3x and square it. In the middle, we're going to take the 3x times the 1. And on the end, we're going to take 1 and square it. Okay, if we take 3x squared, we get, 3x squared, we get 9x squared, good. So both the 3 and the x get squared. 3x times 1 is just 3x, and 1 squared is 1. Once you set up your first little set of parentheses, doing the back set isn't too terrible. Just have to remember to square, multiply, square. Questions on 3 or 4? Are we sure? We're ready for 5 and 6? Oh, well, just kidding. We don't have a 5 and 6. If we have time at the end, we'll go back and make up a 5 and 6. All right, here's where it gets fun. Now we're going to use our new information with our old information. So if we are solving a polynomial equation of this type, meaning a sum or difference of cubes, you're going to first factor it, like we just did on numbers 1 through 4. Use the zero product property, meaning you set each part equal to 0. So you set that little parentheses equal to 0. You set the big parentheses equal to 0. The first one, you can solve it by just getting x by itself. Pretty straightforward. For the second part, because it's still a quadratic, we are going to bring back the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. If you thought we were leaving that in first semester, you were incorrect. Here it is. All right, so for example 5, so if you need to change this on your paper to be example 5 instead of example 7, that's fine. The next example, we now have this set equal to 0. Now, I believe we already factored this. If not, we factored one extremely similar to it, right? Was this the exact same as number 2? Okay, so we have already factored it. That's the first step, is to factor it like we did when we saw this same polynomial on number 2. So if we need a refresher on it, this is a sum, so our signs are going to be plus minus plus. We take the cube root of both of them. The cube root of x cubed is x, and the cube root of 64 is 4. Okay, in the bigger set of parentheses, we have to square the first term. That gives us x squared. We square the last term in the back, and in the middle we multiply them. Good. Okay, square in the front, square in the back, multiply in the middle. All right, so we've already done that for this problem. This time the only difference is we've got it set equal to 0. So when we use the zero product property, each set of parentheses can get set equal to 0. When we do that for our first set of parentheses, we can solve it using our Algebra 1 skills. What do we do? Subtract the 4 from both sides, and we get x equals negative 4. So there's one of our answers. That's already part of our answer. I would circle it so you don't forget about it, because the next part takes a little bit longer. For the next part, it says that to solve x squared minus 4x plus 16 equals 0, we are going to use the quadratic formula. So when we use the quadratic formula, we start off by identifying A, B, and C. What is A?
1.
B? C. Wonderful. Is this all coming back to us now? All right, and then to use the quadratic formula to solve, I'm going to come up here so I got a little space. X equals the opposite of B, or negative B, 4 plus or minus the square root of B squared. So we can just plug it in for now. So negative 4 squared minus 4 times A is 1 times C is, okay, all of that is getting divided by 2 times A, which is 1. Okay, remember plugging all this stuff in? Now we just start evaluating. All right, so when we evaluate 4 plus or minus the square root of, what's negative 4 squared? 16. Minus 4 times 1 times 16. So that gives us 64. All divided by 2 times 1 is 2. All right, we can keep on simplifying. 4 plus or minus the square root of, what is 16 minus 64? Negative 48 divided by 2. This should start looking familiar. We can't divide by the 2 yet. We simplify. We're still simplifying that radical. What happens when we simplify a radical that's negative inside? Good. We would have the square root of 48 times I, but we can also simplify the square root of 48. So if off to the side you want to break down 48, what would it break into? I'm going to give you a helpful hint. Tell you to divide it by 4. 4 and 12. 12 breaks into...
6 and 2.
Don't use 6 and 2.
6 and 3.
Don't use 6 and
4
3.
and 3.
4 and 3. Why did I tell you to do that? Now we have a pair of 4s. Okay, if you were to break it down and get a bunch of pairs of 2s, that would be okay. It's just going to be quicker this way.
You're supposed to break down the 4 though.
So if you break down the 4s, you're just going to get multiple pairs of 2s. They're going to multiply back together to give you 4. Okay, so if you do it that way, that's fine. If it makes more sense to do it that way, that's okay. So 4 plus or minus, this becomes 4 root 3i. Don't forget about the I. If you put the I in a different place, that's fine, as long as it is not under the radical symbol. Okay, and that's all being divided by 2. Still managing to run myself out of room here. Now is when we simplify with the denominator. Okay, so remember, we've got the 4 out in front, the 4 in front of the radical. Those are both divisible by 2, so we can simplify them all. So 2 plus or minus 2 root 3i, and then do we have a denominator anymore? No. Okay, so if it's hard to see down there, I'll rewrite it up at the top. 2 plus or minus 2 root 3i. Okay, so for your answer, you should have circled the x equals negative 4, and you would also circle the x equals 2 plus or minus 2 root 3i. All 3 of those are answers, so this counts as 2 answers with the plus and the minus. I know that was a long problem. Do we have questions about it? Nothing? We're ready to try another one? Okay. Oh, see, it factored it for us. That was nice. All right. So I'm guessing this one will be the same. All right. All right, so on this next example, again, they put in our parentheses for us because we've already done the factoring part of this problem earlier. What was that, number 4? I think. Okay, we'd already factored this before, so they didn't make us do it all over again. So now we've got our 2 sets of parentheses all set equal to 0. We need to set each parenthesis equal to 0 one at a time. The first one is the easy one. 3x minus 1 equals 0. How do we get x alone? Add 1, and then divide by 3. Good. So x equals 1/3. So I would go ahead and box or circle that in as one of your answers right away so you don't forget about it later. Next, we have to take the other set of parentheses and set it equal to 0. In order to solve that one, we're going to have to use the quadratic formula. So we identify the A, B, and C. Who can help me do that? Somebody I haven't heard from yet. Oh, sure, Jacob. A equals 9.
3 and 1.
B is 3. C is 1. Okay. I wonder if I start all the way up at the top, if I'll be able to fit it all in this time. X equals the opposite of B, -3, plus or minus the square root of B squared, so 3 squared, minus 4 times 9 times 1. Good. All divided by 2 times 9. Negative b plus or minus the square root of b squared minus 4ac all divided by 2a. If you don't have that memorized yet, you need to go to bed saying it over and over and over again until it's just seared into your brain. All right, we start off by simplifying. X equals negative 3 plus or minus the square root of 3 squared. 9 minus 4 times 9 times 1. 36, I like it. All divided by 2 times 9. Beautiful. We keep simplifying. Negative 3 plus or minus the square root of negative 27 divided by 18 still. All right, we know that when we see a negative under the radical, that when we simplify, we will have to have I somewhere in there. So x equals negative 3 plus or minus. Now if you need to make a tree for 27, 27 breaks into 9 and 3, and the 9 breaks into 3 and 3. Good. So the square root of negative 27 would become 3 root 3i, all divided by 18. Questions about that step? We're using all those skills from first semester. Now, what do we notice about negative 3, positive 3, and 18? They can simplify. They're all divisible by 3. So x equals negative 3 divided by 3 is negative 1 plus or minus 3 divided by 3 is 1. Remember, the number under the square root never gets simplified at this point, so that stays a 3 under the radical. And 18 divided by 3 is 6. Now, if you choose not to write the 1 that's right in front of the radical, that's okay, but you do need the negative 1 out in the front. And that represents the other two answers. Remember, the plus minus sign means that it's two different answers.